welcome to Wanies Academy. Today we are considering the topic Diamond and Graphite. Diamond and Graphite. The set objectives for this class include the following. At the end of the class, the students should be able to understand 1. The structure of diamond and graphite. 2. Understand the properties of diamond and graphite. Then 3. Understand the uses of diamond and graphite. All right, I start my class. Now, there's something that is certain to every one of us as student of chemistry. There is no element called diamond. Neither is there any element called graphite. So you might be wondering, right, what is the origin, right, or what is the genesis of diamond and graphite? Right, and this can clearly be explained by a phenomenon in science, precisely chemistry, a phenomenon we call allotropy, right? Allotropy. So there's a phenomenon in chemistry we refer to as allotropy. Allotropy. Now, the question then is, what is allotropy? Now, allotropy just means the ability of an element to exist in different forms in the same physical state. I'll go over that again. Allotropy just means the ability of an element to exist in different forms in the same physical state. Now, these different forms of the stated or given elements is what we refer to as allotropes. They are called allotropes. So now, more loosely and clearly, diamond and graphite, they are known as allotropes of carbon, right? So the forms in which carbon can exist in. There are 2 major forms of allotropes of carbon. We have what we call crystalline carbon and the non-crystalline carbon, right? So diamond and graphite, they are 2 crystalline allotropic forms of carbon. So let's bear in mind that diamond and graphite, they are not elements. However, they are forms of carbon, which we correctly call allotropic forms of carbon. All right, so having said that, I would like to quickly explain the structure of the allotropic form of carbon called graphite. Now, firstly, graphite exists in layered form, right? Now, let me display the structure of graphite for us to see. Now, here is the structure of graphite. This is graphite here. Now, this is the structure of graphite. So, graphite mostly exists in layered form. Now, where the carbon atoms in graphite form hexagonal ring, 6-sided hexagonal rings, in such a way that they will eventually create honeycomb-like structure, right? Looking like the honeycomb-like structure of the honeybee, right? Now, if this happens, the layers are usually placed one on top of the other. As you can see in this diagram, now here is a layer, right, which is forming a hexagonal ring on top of another layer, right, and on top of another layer. So simply put, the graphite structure is in layered form. So where they create hexagonal ring, 6-sided structure, right? So in that sense, this hexagonal ring, what they basically entail is this. Each carbon atom is bonded covalently to 3 other carbon atoms. Now, bear in mind that these layers, they are held together by weak van der Waals forces. One of the forces of attraction in chemistry, as a matter of fact, one of the weakest forces of attraction in chemistry is the weak van der Waals forces, right? So the forces holding these layers, one on top of the other, they are weak van der Waals forces. However, these forces do not hold the carbon atoms together. It only holds the layers together. So the carbon atoms are held together by covalent bond, which are very strong and rigid in nature. Now, the structure of graphite can correctly be described as a giant covalent structure, where each carbon atom is covalently bonded to 3 carbon atoms, creating a continuous layer of 2-dimensional crystal lattice structure. So that is how graphite is structured, right? So having talked about the structure of graphite, now let's quickly look at the typical properties of graphite. Now, firstly, graphite is soft and it flakes easily. It's a very soft and flaky substance. Now, this arises from the fact that graphite exists in layered form. So the layered form of graphite accounts for this, the softness and the flaky nature of graphite. Then secondly, graphite is relatively dense in nature. Graphite is known to have a density of about 2.3 gram per centimeter cube. Right? That is relatively high. Then thirdly, graphite is known to have a high melting point. The melting point of graphite, right, is about 3,650 degrees Celsius. That is quite high. The melting point of graphite is about 3,650 degrees Celsius. Now, this melting point arises from the fact that the bonding existing between the carbon atoms, which are strong covalent bond, right, holds the atoms together. Therefore, a very high amount of heat energy is needed to break these bonds. So this accounts for the high melting point of graphite. Then another property of graphite is that graphite is a very good conductor of electricity. Now, this arises from the fact that not all the 4 valence electrons of each carbon atom in graphite is used in bond formation. So out of the 4 valence or outermost electrons in each carbon atom of graphite, only 3 are utilized or used in bond formation. So that means for each carbon, we still have 1 free valence electron free. So in essence, we have enough mobile electrons in graphite. So this accounts for the high conductivity of graphite. So graphite is a very good conductor of electricity. Now, quickly, I would like to go to some of the uses of graphite. Now, graphite being a very good conductor, because I remember stating just some seconds ago that graphite is a good conductor. Now, graphite being a very good conductor and chemically inert, because it's not chemically that reactive, makes it a suitable electrode in dry cells, right? In dry batteries, we usually use graphite as electrode since graphites are very good conductors of electricity. Then there's a mixture of graphite and clay to form what we call lead. Now, this lead is commonly used in pencil. So industrially, graphite is usually mixed with clay to form what we call lead. So and this is used as the nib of a pencil for writing, right? All right, so now having talked about graphite, now let's quickly look at the other allotrope of carbon called diamond. So there's another allotrope of carbon that we call diamond. Now, diamond. Firstly, let's take a close look at the structure of diamond. Now, this is the structure of diamond. Now, firstly, diamond is a tetrahedral crystal structure. It's tetrahedral crystal structure. Tetra meaning that you have 4 sided arrangement, tetrahedral structure, where each carbon atom is bonded to 4 other carbon atoms in diamond, right? Now, this arrangement makes diamond to have a very strong, rigid, 3-dimensional crystal lattice structure. So, diamond is known to have a tetrahedral structure where each carbon atom is bonded or linked to 4 other carbon atoms from the word tetra, 4 other carbon atoms, right? So, this gives rise to a very strong, rigid, 3-dimensional crystal lattice structure in diamond. Now, this tetrahedron structure of diamond, they are usually linked together to form a continuous 3D repeating pattern of giant covalent structure for diamond. So, this is the typical structure of diamond. So, you can see, so we have each carbon atom bonded to 4 other carbon atoms. So, giving rise to 3-dimensional crystal lattice structure of diamond. All right, so then having said that, let's look at some of the typical properties of the allotrope of diamond, of carbon called diamond. Now, number 1, diamond is the hardest known natural substance. I need to say that again for emphasis. Diamond is the hardest known natural substance on the surface of the earth. Diamond is so hard that no other substance can cut diamond. apart from diamond itself. So the hardness of diamond is well known across the globe, right? Then also, diamond is quite dense. As a matter of fact, diamond is denser than graphite that I spoke about some seconds ago. So the density of diamond is about 3.5 gram per centimeter cube. So because of the crowdiness of the carbon atoms, how the carbon atoms are crowded in carbon, right? This accounts for the hardness of the allotrope of diamond, carbon called diamond. So let's bear that in mind. It's the hardest known substance. Secondly, it's very dense, and the density of diamond is about 3.5 gram per centimeter cube. Then thirdly, diamond has a very high melting point. The melting point of diamond is about 4,025 degrees Celsius. That is quite massive, right? It has a very high melting point. So the melting point of diamond is about 4,025 degrees Celsius. Now, this can be accounted for due to the strength of the covalent bond holding the carbon atoms present in diamond, right? Now, I haven't stated the properties of diamond. Now, let's quickly look at the uses of diamond. It has a number of relevant uses. Now, firstly, due to the hardness of diamond, diamond is mostly used industrially in drills for mining. There are some drills we use in mining because whenever we are mining, we drill through rocks. Therefore, these drills need sharp pointers. So these drills are usually made of diamond. Due to the hardness of diamond, they are used industrially in making drills that were used in mining. Then secondly, diamond is also used as abrasive for sharpening very hard tools like metals. So metallic tools, they can be sharpened with diamonds. Then diamond are also used, it's also used for cutting of glass and metals precisely. So this type of cutting is usually of precision type, very, very precise and accurate. Then also, diamond is known to have a very high dispersion power and refractive index. Now, this makes diamond to have a very sparkling brilliance. So diamond has a very sparkling brilliance on account of its refractive index and dispersion power. So if diamond is cut and polished, it has a very sparkling nature. This makes diamond a very relevant jewelry. As a matter of fact, as it stands today, diamond is the most expensive jewelry on the surface of the earth. So no other jewelry comes close, right? In terms of price, as per world market, right? So with that, we draw the curtain on today's class. So please do not forget to share this with family and friends and share and like. Thank you very much. And please do not forget to share this with family and friends. And please click on the button. Thank you very much.